out in an expanded molecular formula. Like this. There is a plane of symmetry in this particular molecule, right down the middle. These two methyl groups are the same. If we put chlorine here, it's the same as if we put it here. If we put chlorine here, it's the same as if we put it here, because we'll make the same molecule. But these two groups in the middle, these are definitely different from these outer groups. We're going to learn right now that when we have more complex alkyl groups, that there's a way that we can describe or give some new type of characterization to this type of carbon. This carbon here, we're going to call it primary. This is a carbon atom attached to one carbon. This carbon here, how many carbons is this carbon attached to? 1. This is also primary. The central carbon, how many carbons is it attached to? 2. It's called secondary. These types of carbons on face value are different from one another energetically and in terms of their structure, and we're going to start characterizing things, calling them primary or secondary, or tertiary, etc. We'll practice this a lot. It'll help us understand radical stability too. Let's just very briefly talk about propane. And I want to set up some problems for you to finish in or fill in the work on your own. So the initiation step is done. We have chlorine radical, but we take propane, and I want us to expand the primary carbon. And in a second example, we're going to take propane, and we're going to expand the secondary carbon. So notice these are both propane molecules. And we know there's two different types of carbons in them and two different types of hydrogens. And this is how we actually predict those products formally or explain those products on the previous page. I was just asking you to think. Draw in what products you think can result from propane. And these are the products I was hoping you'd get to. But if I asked you to explain the formation of those products, you would take propane, and in a propagation step, we would react it with chlorine radical. And we know that this would lead to a primary radical plus HCl. Okay, so this would be the first propagation step of propane. If we're working at the primary position, chlorine can pick off this carbon-hydrogen bond, take that electron, it would make this primary radical. Then this reaction continues in a second propagation step. I want you to fill that in on your own. Okay, so the first propagation step is here. The second propagation step will have Cl2 here. We'll have a chlorine radical here, but we take this particular primary radical, put it here, do the mechanism, and we get a product here. Okay, but in this other possibility, to help us explain 2-chloropropane, to do that, we'd have to draw a mechanism where the chlorine radical plucks off a hydrogen from the secondary position. Let's just draw the resulting radical that forms from that. And we can see here that we've made a secondary radical. And we can see already this mechanism is helping us explain where chlorine is ultimately going to go. In one case, you'll have 1-chloropropane. You'll have to figure that out on your own in the second step. In this case, we made a secondary radical. If this finds Cl2, that's how we make 2-chloropropane. And again, these little boxes I'm filling in here, I want you to do the second propagation mechanism on your own. Okay? Maybe right now, this very minute, would be too difficult for you. That's okay. As you practice these notes, these little boxes here are for you to fill in on your own. Okay? So on your own, please fill in these boxes as you're practicing the notes. It should be very, very self-explanatory. You should be able to do it on your own. If you can't, there's no reason to be ashamed about it. We'll talk about it in office hours. But what I'm hoping is that you can fill this out on your own. It's sort of a self-guided exercise I've designed here for you. Okay? I'm not going to do those for you. You're going to do those. We'll talk, let's just do a little expanded or a review or quick review on nomenclature. We're going to talk about alkyl groups in particular. We know that this group is called a methyl group. When we have a CH2 group attached to something else, this is called methyl ene. So I'm going to use this language. I'm not going to ask you it, but I'm going to use this language. And I'm expecting that you can keep up with me on this particular language. These things over here are carbon, but the group itself in the box is called a methyl group. This group here, where we have carbon attached to one hydrogen, is called methine. Okay, so I just want us to know the difference between a methyl group, a methylene group, and a methine group. Okay. The compound CH2Cl2 is called dichloromethane. And in laboratory, sometimes it's referred to as methylene chloride. This is kind of a common name. This is more of an IUPAC name, but this methylene comes from the fact that we have a CH2 group attached to other things. The other key point I want us to point out now, we're going to use this language tertiary, secondary, primary, and methyl frequently. Again, I'm just going to point this out. That this type of carbon is called primary. It's attached to one carbon. A secondary carbon is going to be attached to two carbons. A tertiary carbon is attached to three carbons. And if you attach a carbon to four carbons, it's called quaternary, or 4 to this little degree sign. That's not important so much for us. But this methyl group right now is written as primary, secondary, tertiary. This little, just really brief and simplistic activity is going to be so that we can communicate clearly about problems with lots of carbons in them. We could say, oh, find all the tertiary carbons. Find all the secondary carbons. That type of discussion and dialogue I want you to be ready for to have with me. Okay, we're going to go back to propane. Thankfully, we'll stall a little bit here, and we're going to take propane and think about it again. When we reacted with chlorine, with UV, let's say, under monochlorination conditions. So we're only going to think about all the possibilities where we only substitute one chlorine onto this molecule. We know already that we make some 1-chloropropane, and we make 2-chloropropane, and we're going to just look at the outcome of this particular reaction, percent yield. The number that I'm going to fill in here, you can't calculate, and you don't need to memorize. Okay? So I'm going to put this in here. Don't memorize it. You can't calculate it. If you want to know the answer to this problem, you have to go in lab, do the experiment, and measure it yourself. So this is an experimental outcome, and we're going to get back to it in just a second. First,